1.4.3, we're going to be modeling with functions. So we're going to model a function from a given scenario. The importance of mathematics to our society lies in its value to approximate or model real-world phenomenon. Whether it be used to predict the high temperature on a given day, determine the hours of daylight on a given day, or predict population trends, mathematics is second only to literacy in the importance of humanity's development. It's important to note that when math is used to approximate reality, there's always limitations to the model. For example, suppose grapes are on sale at the local market for $1.50 per pound. Then 1 pound of grapes costs $1.50, 2 costs $3, and so forth. Suppose we wanted to create a formula that relates the cost of buying grapes to the amount being purchased. We'll say C is cost in dollars, G is the number of pounds of grapes. So creating that, I could say C, the cost, equals 1.5 times the pound of grapes. And so if I bought 1 grape, or 1 pound of grapes, 1 times 1.5. If I bought 2 pounds of grapes, 2 times 1.5, that's 3. That's why it's going to cost $3. Now, if I wanted to take this model and use the language of function notation, I would actually write it like this, where I now create this input-output process. So C of G becomes the cost in dollars, and G is still the number pounds of grapes. So, again, using this model, if I wanted to plug in 1, that means G is 1 pound of grapes. I'm finding where it's 1 pound of grapes. If I wanted to find 2 pounds, G is 2. You're plugging in 2, so 1.5 times 2. Now, even though mathematically there's no restriction to the domain, there is an implied domain to this scenario. Now, the implied domain is going to be a domain that just naturally exists because if you logically think about it, it wouldn't make sense. Now, for this instance, can I go to the store and purchase a negative pound of grapes? No. So G couldn't be any negative number. Can I go to a nearby store and purchase 1,000,000 pounds of grapes? No, no one has 1,000,000 pounds of grapes on hand. So we have to consider the realism of our scenarios. So let's look at this example here. The height, h, in feet of a model rocket above the ground in t seconds after liftoff is given in this scenario. Now, we probably haven't seen a function like this before. We call this a piecewise function. It allows us to break up the function into multiple parts based on a given domain. So the x values that I want to pick. So this is true, this function would be true if my domain is between 0 and 20. This function is true if it's greater than 20. So if it says find and interpret h of 10 and h of 60, I need to think, where could I plug in 10? Well, I can plug in 10 to here because 10 is between 0 and 20. And I can plug in 60 into this one because 60 is greater than 20. So let's go through that. So plugging in 10 into the top equation, negative 5 times 10 squared plus 100 times 10. You simplify that, you're going to get 500. So because we were talking about feet, the height is going to be 500 feet. And then for the other equation, since 60 is going to be greater than 20, h of 60 is going to be 0. Because no matter what you plug in, it's going to be 0. Now, what does this mean? So the interpreting part, that 500 was 500 feet, and at 0, it means it hit the ground. If I wanted to find or solve h of t equals 375, that means you take your equation and you set it equal to 375. Well, it's a quadratic equation. So I have to subtract 375 to both sides because we want our quadratic equations to equal 0. We also like our a to be 1 if possible. Well, there's a 5 in common with everything here, so I can divide everything by -5. And then from here, we got to see if we can factor. A times c, 75. Factors of 75 that add to -20 are going to be 5 and 15, so -5 and -15. So we can factor it, zero product principle, set each one equal to 0. We get t equals 5 and t equals 15. So to interpret what that means, at 375 feet, if I wanted to know what time it would be at 375 feet, my time would be 5 and 15 seconds. Let's look at another one. An online comic book retailer charges shipping costs according to this formula. Again, it's a piecewise. If it's between 1 and 14, we use the top equation. If it's greater than or equal to 15, we use the bottom equation. So what would be the cost to ship 10 comic books? Since 10 is between 0 or 1 and 14, we know we have to use the top equation. So I plug 10 into the top equation. So 1.5 times 10 plus 2.5, that's going to give me $17.50. So then, what is the significance of the formula S sub n equals 0? So what basically this means, if I know that an online comic book retailer charges shipping costs, right? If it's shipping costs, then if it's greater than or equal to 15 comic books, then I know that I don't pay any shipping fees. So it's going to be free shipping. One more. For n copies of the book, Me and My Sasquatch, a print on-demand company charges C of n dollars, where C and n is determined by this formula. Find and interpret C of 20. So we have to look. Where does 20 fit in? Is it the top, the middle, or the bottom? In this case, 20 is between 1 and 25. So I'm just going to plug in 20 into that top formula. And so it's going to cost $300 for the 20 copies of the book. How much does it cost to order 50 copies of the book? And what about 51? Well, if I order 50 copies of the book, 50 is going to fit into the middle equation because 50 is less than or equal to 50. So I'm going to plug in 50 into that middle equation. And so it's going to be $675 for 50 copies. You just multiply 13.5 and then times 50. And if it's for 51 copies, well, 51 is greater than 50, so we're going to use the bottom equation. So 12 times 51, it's going to cost $612 for 51 copies. What did we learn today? We talked about modeling functions, and we also looked at piecewise functions. Now, what's the importance of modeling? It allows us to take real-world scenarios, real-world applications, and be able to create equations and formulas for us to be able to model and examine. This does conclude our lesson. If you have any other questions, please leave them in the comments.